Swayam Prabha. Digital India. Educated India.
Hello dear friends, welcome to this fourth lecture of Module 7 on effect of geological structure on stability of dam foundations and tunnels. In previous discussions we have elaborated about the concept of different type of geological structures like fold, fault, joints, unconformity in brief to create a platform for understanding the different type of features associated with geoground. In these lectures we will try to discuss about major geological structures like fold, fault, joints and unconformity, particularly related to their effects on stability and safety as well as survivability of dam structures, particularly as effect on dam foundation. In this lecture we are going to see about the effects of bedding, folds, faults, joints and unconformity on stability of dams. Regarding this we are going to cover about some introductory aspect, then major structures affecting the stability of dam, then effect of bedding including foliation, schistosity, lineation, all type of linear structures, then folds, faults, joint and unconformity. Friends, as you know, the major structures like fold, fault, joints and unconformity representing the interfaces or discontinuity aspect, therefore affect the foundation, particularly related to stability. Here you can see the fold, faults, bedding, joints, unconformity are generally existed in geological ground, and the dams are constructed on geological ground. Therefore, the structures present in ground is recognized as geological structures, and the geological structures is going to affect the characteristic of rock strata in view of strength, in view of porosity, in view of permeability, etc. Therefore, these structures are often traverse the geoground recommended for construction or construction sites or sites for the mitigation measures related to natural hazards, etc. Among these, some of the structures occur on construction side of engineering structures result favorable and unfavorable responses with respect to forces acting on dam due to construction of dam structures or due to other components related to dam project like water in reservoir, some effect related to wind flow or sometimes related to earthquake, etc. Therefore, the geological structure inherited in strata or geoground lying below the dam foundation and reservoir bottoms sometimes create lot of critical problems. Thus requires costly treatments, measures and delayed in completion of work as well as uncertainty about the stability, survivability and safety of dam project. It may also cause frequent repair even in post-construction phase of dam, and in this way going to enhance the cost and create lot of uncertainties. First, we are going to discuss about the effect of folds on dam foundation, particularly synclinal fold. The deformed structures like fold can be of much importance from construction engineering structure, for construction of engineering structure point of view, concern to stability assessment, etc. And their importance can be as follows. The folding present importance in location of dam or the fold structures located in dam foundation have special importance, and the site chosen for dam construction is contain fold. The inclination of limb in the dam site may produce a geological setting which may either favorable or unfavorable at the dam site. So the presence of fold may be favorable and may be unfavorable. The presence of beddings also sometimes favorable, sometimes unfavorable, but presence of joints are not favorable, and unconformity is also not going to support due to interface present in unconformities. First case, we are going to discuss about the strata of fold limbs dip gently in upstream. Here, strata of fold limb dipping gently towards the upstream side. In this case, if the dip holds limbs dipping gently in upstream direction, it is more favorable and advantageous. And this is because at the dam side, the weight of dam, that is the W, weight of dam W acting downwards, vertically down, and in addition there is also exist a great lateral thrust due to presence of water. Due to presence of water, there is hydrostatic forces acting on dam following the calculation related to this area of triangular multiplied by unit weight of water. Beside this, the time to time the waves generated on the surface also going to influence the structures and the load transfer towards the bottom of the dam. Here we are considering the impact of water in form of hydrostatic force or pressure or thrust acting on the dam and affecting the dam foundation. The resultant force R of these two will always inclined in the downstream direction. As it indicates, if we are going to trace this is acting normal to this bedding belonging to the limb of fold, and depending on the significance of the reservoir water, the inclination R may vary from the 10 degree to the 30 degrees from the vertical, and it indicates that the bed which have a gentle upstream dip will be perpendicular to the resultant force. Hence can offer their best competence withstand the stresses or loading acting on the area. So this situation is a favorable, and dam can be constructed safely, economically, and without uncertainty in future safety problem. Next type of condition associated with this type of situations where the limbs are folds dipping toward the upstream. Normally the sedimentary rocks we are having strong bearing capacity, and when force act perpendicular to the bedding planes at the same rock have the least competence when the force act parallel to the bedding planes. In this point of view also, these limbs of folds dipping toward the upstream is found safer. Next case is strata of fold limb dip gently toward the downstream side. Here downstream side. In this case, the resultant force of the dam will be parallel or nearly parallel depending on the amount of dip of the limbs. In this situation, the sedimentary beds or any rock strata, any metamorphic foliated rocks or schistose rock are less competent, leading to unfavorable geological setting. In this situation, there will be problem of leakage due to flow of water inside this bedding, and due to flow of water there is a development of upthrust which are going to minimize the effective weight responsible for stability of dam. In such situation, the thrust is dominating and this weight is less, therefore the resultant is towards the downstream side. Due to this, there is problem of instability, because this whole situations going to induce instability problem, slippage and others, and this whole may slide, resulting the slide of dam foundation and ultimately failure of dam foundation. Next case we are discussing. The similar case we can observe in case of anticlines also, but anticlines are more competent than the synclines. Here only this zone required treatment by suitable material, because lot of fractures and joints develop here and make this region weak. If we are going to treat this region, otherwise this type of situation is generally favorable in case. Therefore, we are discussing about the synclinal, which are prone to leakage, creation of upthrust and resulting problem related to instability. Next type of problems we are going to discuss about strata related to bedding. If the strata is lying horizontal with respect to this dam structure, then there is a problem of percolation of water or leakage of water, and that leakage of water going to accumulate here and create upthrust, upward acting force, that is going to push the dam foundation up and going to reduce the effective role of weight of dam. In this way, the resultant is shifted toward the downstream side and resulting lot of problem concerned to stability. But as the bedding is horizontal, therefore the bedding is competent enough. Therefore, such type of problem can be encountered. Here the geological setting of folds are simply beddings or limbs of folds is going to contribute the stability and eliminate the possibilities of uplift, and this is because if any possible leakage of the reservoir is directed to the upstream by virtue of inclination of bed. So here we are discussing about the horizontal bed. In case of these horizontal beds constructed on horizontal strata, we are not going to see the major problems, but there is accumulation of the water that going to push the dam up. However, the horizontal strata is able to bear the load, therefore such situation may be problematic, may not be problematic. So balance in nature can be, the dam can be constructed after careful treatments and others, not very adverse in condition. If this strata is running vertical, either belonging to the fold limb, either belonging to the general bedding, if the strata is perfectly vertical rather than uncommon, as strata will normally have certain inclination, but if vertical or with close to the vertical at high angle, then it will not pose problem of uplift pressure on dam or leakage below the dam, because the filters water may enter in very deep. However, it shall not have any advantage in term of competence of the rocks given place. It will not pose problem of the uplift pressure on dam or leakage below the dam. However, it shall not have any advantage in terms of the competence of rocks. Although we have discussed, in general, if we are going to test the rock block with perpendicular and with a horizontal parallel to the axis, perpendicular to the axis, then the minimum strength we are getting at the position where these beddings or stratum is inclined at 45 degree, then have considerable value in case of parallel and perpendicular. So in such situations the strata may be sufficient to bear the load in view of the strength of bedding or rock mass, etc. These are able to bear the thrust and others. Here this resultant is acting this oblique too, but this vertical extension of the beds responsible for bear the load of resultant as well as weight as well as thrust. The strata steep deep, having steep deep in downstream side. In this situation, all the disadvantages occurs where the filtration of water going to create upthrust, upward acting force, as well as the resultant force and the bedding planes are nearly parallel to each other, which means that the bed will be less competent and may be prone to slide. The material and figure created based on the written Engineering Geology Unit 4, page 4 to 33 by the Shiva Vartha Murthy, and I have given reference also. So in this way we are going to elaborate about the effect of fold limbs, syncline as well as anticline have minimum problem except some crustal zone require treatment. Next aspect is effect of fault, and friends, as you know, the fault zone is a weak in nature, having friable materials like goop and other deformed rock, fault breccia and others which are not more competent in support of weight related to dam as well as thrust. A fault zone lying under the dam is composed of weak goo material with low modulus of elasticity strength as compared to the sound rock exposed in fresh rock condition. Therefore, the presence of fault zone induced more stresses in foundation as compared to the normal situation. A fault in foundation is thus a source of weakness to the foundation and creating lot of problem related to seepage, percolation and loss of strength. The source of weakness to the foundation and careful studies are warranted to tackle this problem, and the fault movement will cause cracks in almost all concrete dam, whereas the differential foundation movement resulting due to presence of weak material associated with the fault zone. And good examples we have such type of deformation is the Jurier Arch Dam located in Switzerland, and fracturing was observed in this dam due to presence of fault or due to low strength of fault material. In different positions the faults are going to influence the stability of dam. First case we are taking here upstream vertical fault. If the vertical fault is located away from this dam foundation in upstream side, then what happens? It does not pose a serious foundation problem because it is located away from dam foundation. The vertical stresses induced are of low order and the fault zone does not warrant elaborate treatment measurement or the mitigations measures. However, care should be taken to ensure that the horizontal tensile stress is within the safe limit. If the tensile stresses are more, then require some treatment and careful observations. It is pronounced up to a depth equal to only half of the dam height. Therefore, in an upstream vertical fault, only the zone extended downstream of the fault need treatments. If this fault is located here in upstream and extended up to downstream like this, then problem. If it is a vertical, then not more problem. If any branch of this fault, although vertical, is extended up to downstream, then there is a problem. So this type of situations only require some feeble type of treatment or low level of treatment, if depending on the amount of induced horizontal stress. Next type of fault location, central fault inclined upstream at an angle of 45 degrees. If it is located in upstream side and below the foundation of dam, then what happens? If the orientation of fault in such way, only a small part of the fault stress is within the dam base, then the stresses induced are similar to the normal foundation. If this fault is located here, only affecting the part of dam, then not going to affect more, not create more problem. If going to locate in partial part, then also not going to affect. If this fault zone is extended or considered the major portions of the dam foundation, that it is a problem. This concept is true when the fault is inclined to upstream. In such cases, a dam can be built with the minor foundation treatment, and more treatment may be necessary to control seepage, which is dependent on the permeability of rock mass caused due to presence of this type of fault located in upstream at inclined position. Next type of fault is centrally located vertical fault. The centrally located vertical fault is entirely inside the dam base, indicating compression on the downstream and the tension on the upstream side. Therefore, for such condition, a probe is necessary for the whole foundation mass, and proper treatment measures should be adopted carefully, seriously, and time. Next type of situation, if the central fault inclined downstream, upstream we have discussed, vertical we have discussed, and then downstream at an angle 45 degree towards the downstream. Friends, you know, this is the upstream side, this is the downstream side. This region we have already discussed, headwater region, this is the tailwater region, and this is the crest, this is the body. So this orientation of fault deserves full attention and may pose serious problem to design engineers or stability of dam. The presence of this type of fault induced large stresses in foundation. An increase in stresses is about 75% to 100% as compared to the normal foundation. Due to enormous increase in stress, there is a problem associated with the faults lying toward the downstream side below the foundation and ranging in degree 45 degree and close to 45 degree. Though horizontal normal stresses does not change much, and the vertical normal stresses and principal stresses tend to reach alarming proportion and resulting the damage of the foundation, where this material of the foundation is unable to bear such situation and started settlement, resettlement, and resettlement induce the instability and create question in way of survivability. Survivability means long-term safety. The fault at the downstream but located near the toe side, we have already discussed. This is the heel side and this is the toe side. So in such situation, the stresses on the upstream side of fault are more pronounced than those on the downstream side. Therefore, careful foundation treatment is necessary for the foundation under the dam. And the tensile stress condition, the tensile stress is also induced on the upstream at the dam site, and which is smaller than due to central vertical and sloping downstream fault. So this situation is also require proper treatment and precautions and measures. Next is, if the fault is located below the dam foundation, then we are going to develop about plugs. Plugs means going to create gap by excavating this zone, and for excavating these zones we have recommendations from the US Bureau of Reclamation, as we have already discussed in our early discussions, where the D is equal to 0.0066 B into H plus 1.5 for the dam height. H is more than 46 meter, and the D is equal to 0.3 B plus 1.5 for the dam height. H is less than or equal to 46 meter. In some books here the peoples have started writing 000, but this value calculated for the depth of excavation is very limited in such situations, therefore 0.0066 BH is justified, where this D will represent the depth of excavation, and B is representing about the width of fault zone or shear zone, and H is about the height of dam, for which dam we are going to treat the fault located in fault zone and below the dam foundation. This method of fault treatment was devised after studies of fault in the foundation of the Shasta Dam and the Fen Dam in US, and on the basis of this we have generated. The influence of the plug in all cases started stress along the faults and also maximum in the foundation reduces with increase in the depth of plug, and the plug used to treat the fault zone or shear zone is a seal generally of concrete introduced to soft zone after removing the soft material as per this calculation. This soft excavated zone we are going to fill by concrete and make this situation suitable for stability, because in this way we are going to make this zone similar to the nearby zone in view of the mechanical response of rocks and competent enough to bear the load. Beside this, we have effect of joint, as the joints are affecting the strength of rock mass or rock strata. We have already discussed in our rock mass characterization and quality insurance and others. Therefore, the joint present in foundation is going to influence the strength of foundation, directly and indirectly going to direct the stability aspects of the strata, which are under the influence of the weight as well as the thrust caused by the hydrostatic pressure of the water, going to push this dam toward the downstream side. The resultant work, if following the joint plane, majority of joint plane toward the downstream, it is problematic, similar to as we have observed in case of bedding, running or striking or dipping downwards toward the downstream, and similar if upstream no problematic is vertical nearby this zone fault, similar but the presence of joint is going to influence the strength of rock, therefore careful treatment and preparations are required for jointed rock to ensure the sufficient strength availability of the rock strata lying below the foundation of dam, which can able to bear the resultant effect caused by weight of dam as well as the thrust caused by hydrostatic effect of the water present in reservoir, as well as time to time the impact of the waves due to wind in storm condition as well as in normal condition, or agitations creating hydrodynamic force during the earthquake, as well as sometimes in cold region there is a formation of ice and others that going to create pressure due to expansion in balloon. Friends, you know liquid and state and solid state. So ice is a more in volume, expansion in volume, going to create lot of problems nearby the top portion. Beside this, we have also sealed pressure and others. So all the pressures encountered by the weight of dam, and this weight of dam if affected by other forces like upthrust and others, then there is a problem. Related to effect of unconformity, friends, as the unconformity is the interface between the overlying and underlying beds, we have already discussed, are strata having some angular relationship in case of the angular discontinuity, having some parallel arrangement of the younger rocks, older rocks. If the interface lying between the younger and older rocks below the dam foundation, the percolation of water from the reservoir side and following the interface is going to create lot of erosional work and creating lot of accumulation of water, going to push the dam up and going to make the reduction in effective magnitude of the weight of dam. Otherwise, it is not effective in case of this interface lying far below the dam in view of the depth. So similar way of the bedding and others, this unconformity is also going to create lot of problems depending on orientation of interface and the location of interface, how close to the foundation of dam. If it is close to the foundation of dam, this zone is a very weak in nature. The water, percolation water and others creating pipe type of conducts, and this pipe type of conducts is going to enhance the erosion problem and piping problem, particularly in case of dam having heavy weight or heavy structure dam. And due to piping, there is accumulation of this and going to affect. Friends, this lecture's materials I have prepared from the material available in Engineering Geology book written by Gangopadhyay S in 2013, published by Oxford University Press. Then concept taken from the Shiva Bharta Murthy T related to Engineering Geology Unit 1 from page 4 to 33. Then concept given by this Amber W and the Lombard. I have taken example from the paper written in Swiss National Committee on the Large Dam and ranging from the page 102 to 109 as example. Then partial support from the book written by Bell FG entitled Engineering Geology, having page 12551, and then textbook of Engineering Geology written by Kashagulu NC in 2016, ranging page 1 to 435. And the diagrams I have prepared on the basis of literature. Friends, today we have discussed about the effect of faults, fault joint unconformity on dam stability. And friends, fault joints are affecting the stability of dam foundation. As a conclusion, the different positions and alignment of such structures poses various kinds of seepage and stability problem depending on the location of these fault joints and bedding below the dam foundation. Similarly, the fault located at different locations also affecting the stability of dam and the strength of dam, causing seepage and other development of different type of stresses below the foundation and resulting serious to zero problem and recommending for suitable treatment. Joints are also playing very important role, as the joints are affecting the strength of rock strata where we are going to put the dam structures. The strata has to bear the load of the dam structure as well as the resultant effect caused by hydrostatic, hydrodynamic, wave pressure, silt pressure, and this pressure due to ice formation, etc. Unconformities lying below the dam foundation sometimes poses serious problem due to seepage and erosion caused by the presence of the interfaces lying between the overlying older and younger rocks, and it also depends on the orientation and the location of such interfaces close to the dam, or how close to the dam or how far the dam. In these lectures, we have elaborated about the concept related to effect of fold, fault, joints and unconformity located below the dam foundation or close to the dam foundation and in reservoir side or tailwaters. We have elaborately taken some case of synclinal fold, particularly about the limb part and the bedding with different orientation toward the upstream side, toward the downstream side, below the dam, away below the dam foundation, away from dam foundation, toward the upstream side, toward the downstream side, located at the toe side, located at the hillside, etc. In this way, we are going to see about the stability of dam and the effect of geological structures on stability, survivability and safety of them. Rest of geological strata affecting the tunnels we will discuss in our next class. Thank you very much for your patience.